Why would anyone want to build their own ethical hacking tools? The question hints at a deeper curiosity, understanding the machinery that powers our digital world. Commercial tools are powerful, but they can feel like a black box. You provide an input, an output appears, and the process in between remains a mystery. Building your own tools demystifies that process. You learn how systems communicate, how vulnerabilities are structured, and how defenses can be tested. This journey is not about writing malware, it is about education and empowerment. It strengthens digital defenses from the inside out. A simple port scanner teaches sockets, TCP handshakes, and firewall behavior. Before we go further, legality and ethics come first. Before you build a house, you study wood, stone, and steel. Likewise, before building tools, learn the systems you intend to analyze. Start with how computers and networks operate. Understand the OSI model, at least in principle, TCP and UDP. Know IP addressing, subnets, and DNS. Essentials for network tooling. Learn your operating system's internals, file systems, processes, permissions, and the CLI. For ethical hacking, Linux command line fluency is especially valuable. This foundation helps you build better tools and interpret outputs into intelligence. Programming is prerequisite. Python is a superb starting language. Its libraries accelerate networking and security tasks. Learn the language. Vulnerability, exploit, payload, threat surface. Know authentication, authorization, encryption, and hashing. Core mechanisms of defense. With fundamentals set, choose the right language and tools. Python excels for rapid, readable prototypes. Fast feedback keeps you learning. Example outcomes. Discover open ports, identify server versions, small wins, big insights. Libraries are time savers. Scapy crafts packets, requests handles, HTTP, Beautiful Soup parses HTML, shell scripting chains tools, run scans, pipe to grep, and save time-stamped output. On Windows, PowerShell offers deep automation. Use a capable editor. Syntax highlighting, auto-completion, and debugging accelerate you. Track changes with Git. Collaborate via pull requests. Host on GitHub or GitLab. Version control is the backbone of sustainable tool building. Never test systems you do not own or lack explicit permission to assess. Create a safe, isolated lab using virtualization. Tools like VirtualBox or VMware let multiple OSs run as separate VMs on one machine. Use at least two, an attacker VM and a target VM. Install a preferred attacker OS. Many use Kali or Parrot for building and running scripts. On the target VM, run Windows or a basic Linux server. Configure an internal or host-only network. VMs communicate locally without internet access. This prevents accidental public scans and keeps vulnerable services isolated. Populate your lab with intentionally vulnerable targets like Metasploitable or OWASP Juice Shop. These targets provide a legal, educational playground for honing tools and methodology. Ethics and isolation are non-negotiable. With your lab ready, build your first tool, a simple port scanner. Ports are numbered doors used by services, 80 for web, 22 for SSH. The scanner checks which doors are open, closed, or filtered. Flow, get target IP, loop ports, attempt connect, report result. Input the target IP, your isolated lab VM. Start small, 22, 80, 443. Attempt a TCP connection to each port and capture the outcome. Success means open, refusal indicates closed, timeout suggests filtering. In Python, use socket with connectx. It returns 0 on success, non-zero otherwise, then print status. Running this script teaches core network programming and reconnaissance fundamentals. After network scanning, turn to the web. Build a simple reconnaissance script. This tool speaks HTTP. Send requests, analyze responses. Start with checking common paths like admin, backup, or .jit. Input a base URL, your lab target, and loop through a word list, requesting each path. Focus on status codes, 200 OK found, 403 forbidden exists, but denied, 404 not found. Report non-404 results. Those are points of interest. In Python, requests makes this trivial. Requests.get URL, then inspect response.status check code. Use a word list and add a small delay. Rate limiting protects fragile servers. Small, careful steps build reliable tools and sustainable habits. Printing to screen is a start. Logging makes results last. If it disappears when the terminal closes, it never happened. Append your findings to a persistent log file with timestamps. For structure, use CSV, target IP, port, status, easy to sort and analyze. Also, log actions and errors to debug your tools efficiently. Python's logging module supports levels and dual output to console and file. Mirror console messages to logs for complete traceability. Example, timestamp. Info 192.168.1.1.1. Port 80, open. Clarity matters. Design safety into your tools, never as an afterthought. Poorly written scripts can crash fragile services or flood networks. Add rate limits. Delays between requests prevent unintended DOS. Expose delays as a configurable parameter. Validate targets. Restrict scans to your lab's IP range to avoid mistakes. Print a clear legal warning and require typed confirmation before proceeding. Guardrails don't replace due diligence, but they reinforce ethical habits. A port scanner and a web checker are only the beginning. You now grasp protocols, HTTP requests, parsing, and logging, the building blocks of advanced tools. Go deeper with Python and Scapy to craft custom packets and study defensive reactions. Study TCP, IP, and HTTP2 to uncover subtle behaviors for richer reconnaissance. Learn data structures and algorithms to scale efficiently. Share tools on GitHub and learn from community feedback. Read disclosures, write safe POCs in your lab, and participate in ethical bug bounties.